Today we're going to look at simplifying algebraic fractions. Now the rules for simplifying algebraic fractions are identical to those of simplifying numerical fractions. You're constantly looking for that highest common factor. So if we look at 15 over 20, the largest number that will divide into 15 and 20 is 5. So we take both parts of the fraction and divide it by 5. By doing that, 15 divided by 5 is 3, and 20 divided by 5 is 4. So the answer is 3/4. We have simplified or reduced the fraction down to its lowest terms, but it still retains the same value. 3/4 is still the same as 15 over 20. We're going to apply that to algebraic fractions. Now here I have c squared divided by c. If we think about how you make c squared, it's c times c, or c squared times 1. And then if we think about how you make c, well that's just c times 1. That means that the largest common factor is c in both cases. So c squared divided by c will give me c, and c divided by c will give me 1, so then my answer is c. I can also complete this question by expanding out that c squared. So c squared, as we said, is made by c times c. C times c divided by c, well, if I'm multiplying by something and then dividing by it, it's like I never multiplied by it to begin with. Okay, this time we have m cubed over m7. Now you can also solve this by using rules of indices. This is the same as m cubed divided by m7, and we know that rules of indices say that this is going to be m to the power of -4. If I'm doing it in this form, I'm going to have m times m times m, all divided by m times m times m times m times m times m. So 1, 2, 3, 4, 5, 6, one more times m. And then I can just do a process of cancelling. 1 for here, 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 1 for here. So I'm left with 1 over m times m times m times m, which is m4. Both of these answers, 1 over m4 and m to the -4, are equivalent answers. We could also have done this by finding m cubed as the common factor, and then m cubed times m to the power of 4 makes m to the power of 7. So we have 4t over 16t cubed. Okay, so now we're introducing numerical terms as well as algebraic terms. So 4 over 16 will simplify down to 1/4. And then t over t cubed would simplify down to 1 over t squared. So this becomes 1 over 4t squared. Now we have a mix of more than 2 terms, algebraic terms, and we have a numerical term. Now, the absence of a number on the top tells me that it's 1, so we have a half equivalent here, and we don't put the 1 because we don't have 1r squared s. Okay, so half will not reduce, so I'm going to leave my 2 at the bottom and then I'm going to reduce my top. So r squared divided by r is going to give me r, and then s divided by s to the power of 4 is going to give me 1 over s cubed, so then I'm going to have an s cubed on the bottom here. So this simplifies to r over 2s cubed. And if I use the blue pen, I'll show you that this cancels. So the squared will cancel with the r, the 4 will reduce down to a 3, and the s will cancel completely. So I'm left with r over 2s cubed. Now we have bracketed terms, and again the process is the same. We have z minus 1 over z minus 1 all cubed. Well, how do you make z minus 1 cubed? It's z minus 1 times z minus 1 times z minus 1. So a process of cancelling out means that this z minus 1 will cancel 1 down here to reduce it to 2. Having nothing left on the top line means that my answer is going to be 1 over z minus 1 all squared. Another example, we have p minus 2, p minus 4 all over p minus 2 squared. So again, we can see we can cancel. This p minus 2 will cancel the squared part of the p minus 2 on the bottom, and there's nothing we can do with the p plus 4, so my answer is p plus 4 over p minus 2. Okay, feel free to ask me any questions because this can get a bit tricky.